Yes, we'll continue. So based on this definition, a cloud allows workloads to be deployed and scaled up quickly to rapid provisioning of virtual or physical resources. So that means that as and when you make a request to a cloud by using a suitable interface, it will provide you the services. Okay, so that is called rapid provisioning. So, for example, suppose if your demand is reducing, it will shrink the resources that you need, and if your demand is increasing, so rapidly it will scale up the resources, virtual resources. So that's how the cloud provides services to its end users. The next thing is yes. Uh, Next thing is internet clouds. Okay. So the concept of internet cloud is all about interconnecting all its data centers. Okay. Say for example, a very small, for example, a very small organization may have a single data center, and then medium-sized organizations may have some two, three data centers, and huge enterprise-level organizations may have a number of data centers. And when you connect all these data centers together using an internet, we call it as internet clouds. Okay. So therefore, cloud computing applies a virtualized platform with elastic resources on demand. Okay, remember this elastic resources. That means elastic resources means which are which can be scaled down or scaled up by provisioning hardware, software, and data sets dynamically. You can see this diagram. Okay, this you can see this cloud which represents the resources. Okay, like hardware, storage, service, network, software, everything is connected to form a cloud platform. Okay, which consists of multiple data centers that are geographically separated, and you're connecting all those data centers using the internet. And by using the same internet, the end user will consume the services by making request request to the cloud, and cloud will provide value-added services, paid services. And the overall idea is to shift the desktop computing to a service-oriented platform. Okay, once again, I'll tell the overall idea of this internet clouds or the cloud computing is to shift the desktop computing to a service-oriented platform using server clusters and huge databases at data centers. And cloud computing leverages its low cost and simplicity to benefit both users and providers. Okay, so that means cloud computing provides low cost services. Okay, say for example, so as an organization, company cannot procure each and every software. Okay, so they may be having requirements for a specific project, and if the cost is very huge, obviously they go for cloud-based services. That means they'll install virtual machines and they'll consume the what are the softwares that they want. They'll install virtually on their laptops. Okay, and they'll pay for like for daily basis or weekly basis. There will be so many pricing models, so which is appropriate, they'll go with it. Okay, that means cloud computing leverages its low cost and simplicity to benefit both users and the providers. Okay, next concept is the cloud landscape. Okay, so that means what is the context of the cloud and what the cloud can do. Okay, so the context of the cloud is it can provide three types of services, that is software related services,
देखा है
platform related services,
हाँ
and infrastructure related services.
कहाँ गलती किया
Okay, so first we look at infrastructure as a service. So this model puts together infrastructures demanded
रुक
by
जा
users
हाँ लेट हो गया हाँ बोल
like servers,
हाँ बे
storage, networks, and data center fabric. Okay, that means when you say infrastructure, it includes servers. Okay, that's okay. Servers can be like mail servers, file servers, proxy servers, or any other similar kind of service. And the storage. Okay, and the storage is very much essential to store the all the users' data. Okay, and to retrieve it and as and when required. Then the networks. Okay, so the network basically deals with the connectivity, end-to-end connectivity between the data centers and the end users. Okay, then as part of this internet as a service, in infrastructure as a service, the user can deploy and run on multiple virtual machines running guest operating systems on specific applications. That means, so it provides a provision wherein the user can install any guest operating system of his choice, and upon that he can install applications and he can run and test the applications. Okay, that's one of the major benefits of having infrastructure as a service, as a cloud service. In the next service is platform, that is PaaS, platform as a service. So this model enables user to deploy user-built applications onto a virtualized cloud platform. That means being a developer or a user, you can develop your own applications. And when you want to test run it, okay, so you can go for cloud-based platforms. And we call such a service as platform as a service. Okay. Say for example, you have developed one application, say iOS application. Okay, using some IDE you have developed. Now you want to deploy it and you want to test it. Okay, because before making it available to everyone. So if that is your requirement, then you can obviously go for a suitable cloud platform where you can host on a virtualized server and you can run your application and you can test it. Okay, we call it as platform as a service. And PaaS includes middleware support, database support, and it will also provide you some development tools, which are virtualized development tools, okay, which you can actually install on your guest operating systems and you can start working. And some runtime support such as Web 2.0 and Java related services. Okay, next service is SaaS, that is software as a service. This refers to browser initiated software over thousands of paid cloud customers. The SaaS model applies to business processes, industry applications, consumer relationship management applications, that is CRM, and ERP, that is enterprise resource planning applications, and HR related applications, and other collaborative applications. That means cloud will also provide a software as a service wherein you can get the ERP related, for example, ERP related services, HR related services, to get some leads for your business, say CRM services to get some leads to your business. Okay, based upon the number of leads that they give, you need to pay for that. Okay, so that will be provided as part of software as a service. Okay, so therefore mainly when you consider software as a services, the major services that a cloud provides include CRM, ERP, and HR related services. Okay, so by this we are ending the concept of models for distributed and cloud-based systems. Okay, so any doubt in this? Yes. Hello. 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 Okay, along with this, okay, I want to tell you something about how to design a data center for cloud cloud purpose. Okay, so that is designing data centers for cloud platforms. So here, one thing is very important. That is whenever we think about designing a data center for cloud platforms, we need to think about cost effectiveness. Okay, in this chapter, our main focus is on so what kind of systems that we need to use and how to minimize the cost. So first of all, as part of resource procurement, we need to think about commodity systems. So commodity systems, for example, the x86 based machines are called as commodity systems. Why? Because they are the fast moving systems and the cost incurred is very less. So instead of buying dedicated servers like dedicated IBM server, IBM file server, or IBM mail server, or something like that, we can go with commodity systems and we can add extra RAM and storage and we can utilize them. And same thing can be applied while procuring the switches and other network equipment. Okay, so we need to procure commodity switches instead of going for robust switches and all. So like this, you can reduce the cost of the data center. Okay, so why? Because when you say data center maintenance, so usually we spend approximately 16 to 80% of the money to procure the hardware resources like processors, networking equipment, computers, and other hardware resources. And remaining 80 plus percentage of the amount will go for other maintenance related things like to to procure fuel and to spend for AC and cooling effects and to pay for the admin and other related things. So hence the major cost incurred in data center is okay other expenditure except from the hardware resources. Okay, so therefore while procuring the items for the data centers, we need to rely on commodity systems, which are x86 based systems and commodity switches. And it is suggested to go with the Ethernet technology, gigabit Ethernet, okay, for internal connectivity of the data centers. Thank you.